This is Mr. Beck Does Your Homework, Homework 22, questions 14 through 17. A 22, 9, and 8 ohm resistor are connected in parallel to an EMF source, which is a battery. A current of 6 amps is in the 9 ohm resistor. Calculate the equivalent resistance of the circuit, answering units of ohms. So let's see, this is a parallel circuit. So let me draw these 3 resistors in parallel with the battery. So there's my battery. There's one resistor. There's another resistor. There's another resistor. All 3 of those will connect back into the battery. So this is 22 ohms. This one is 8 ohms. And this one is 9 ohms. And this tells me that 6 amps is in the 9 ohm resistor. 6 amps is in the 9 ohm resistor. They want the equivalent resistance of the circuit. Well, that really doesn't deal with this, but I've got these 3 resistors that I need to combine to give me equivalent resistance for that circuit. So I know that 1 over my total resistance is going to equal 1 over the first resistor plus 1 over the second resistor plus 1 over the third resistor. So this is 1 over our total equals 1 over 22 plus 1 over 8 plus 1 over 9. And if you remember how to do this on your calculator, you're going to use your inverse button, your 1 over button. So let me just pull out a calculator to show you how this works. I have a button that says x to the minus 1. So the easiest way to do this math is going to be 22 inverse, that's 1 over 22, plus 8 inverse, yours might be 1 over x or x minus 1. So 22 to the negative 1 plus 8 to the negative 1 plus 9 to the negative 1. So that's my 1 over 22 plus 1 over 8 plus 1 over 9. I'm going to hit equals. That number is not our total. That's 1 over our total. So I need to, again, hit that x to the negative 1 button and hit equals. And that gives me my equivalent resistance of 3.55. 3.55156. So that gives me my equivalent resistance, my total resistance of the circuit. So that is question number 14. Question number 15 says, what is the potential difference across the source? So I want to know the voltage here. Well, conveniently, the voltage here is the same as the voltage here, is the same as the voltage here, is the same as the voltage here. And here I can calculate the voltage, because here V equals I times R. My I is 6 amps, and my resistance is 9 ohms. So for me, my voltage is 6 times 9 is going to be 54 volts, and you'll get your own voltage there. So if that's the voltage here, that's also the voltage here, that's also the voltage here, because in parallel, all the voltages will be the same, all the potential differences. Because if I go up 54 volts, I'm going to come down 54 volts, I'll be back at 0. Same thing here, up 54, down 54. So no matter what branch, I'm going to get that voltage. So that's question 15. Question 16 says calculate the current in the 22 ohm resistor. So now I know that the voltage is going to be the same because the voltage is the same everywhere. So for the 22 ohm resistor, I want the current. So I'm going to get I equals V over R. So for me, that's going to be this 54 volts divided by my 22 ohms resistance, and that's going to give me my current through that resistor. Now it says calculate the current in the 8 ohm resistor. Again, same thing. I'm going to do I equals V over R. The voltage is the same across each resistor, so that's going to be 54 volts that I calculated before. And that's going to be divided by that resistance of 8, and that is going to give me the current in that one. So that is question 17.